On December 21st, 2025, an object older than the Sun itself was already leaving us behind. At over 130,000 miles per hour, it was racing out of the solar system, never to return. No explosions, no signals, no dramatic farewell, just a silent departure. Its name was 3I Atlas, officially catalogued as C2025N1, only the third confirmed interstellar object ever observed passing through our solar system. And yet, despite its quiet exit, this object has left behind one of the most important scientific puzzles of the decade. Not because it was artificial, not because it was hostile, but because it forced us to confront a humbling truth. The galaxy is busy, and Earth is not the destination. Tonight, we tell the full story of 3I Atlas, what it was, what it wasn't, and what its silent journey reveals about our place in the universe. Chapter 1. A visitor from another star, 3I Atlas was not born here. Its velocity, trajectory, and chemical fingerprint all point to an origin beyond our solar system, likely formed billions of years ago around a star that may no longer even exist. Unlike comets bound to the Sun's gravity, 3I Atlas followed a hyperbolic orbit, meaning it was never meant to stay. It entered from interstellar space, passed through, and left, unchanged by our presence. Its path was clean and elegant. Sun, Earth flyby, Jupiter gravity assist, exit no deviations, no corrections, no hesitation. By December 19th, 2025, it made its closest approach to Earth. 2 days later, it was already far beyond our reach. But during that brief window, astronomers gathered an unprecedented amount of data, and what they saw challenged decades of comet science. Chapter 2. The Heartbeat in the Dark. The first anomaly was subtle, almost easy to dismiss. Astronomers noticed small, rhythmic fluctuations in brightness, a pattern that repeated with striking consistency. They called it a heartbeat. Unlike violent flaring or chaotic outgassing, this pulse was gentle, controlled, steady. The most likely explanation? Rotation. As 3I Atlas spun, different regions of its surface warmed and cooled, reflecting sunlight differently. But here's the problem. Most comets are rubble piles, loosely held together conglomerates of ice, dust, and rock. Their rotations are chaotic. Their brightness curves are messy. 3I Atlas was different. Its pulse suggested a solid, cohesive interior, uneven mass distribution, a complex rotational motion, like a wobble or precession, rather than a simple spin. In other words, this wasn't a fragile snowball. It was dense, robust, and capable of surviving forces that would tear normal comets apart. That realization led directly to the next, and much bigger, problem. Chapter 3. The Spin Paradox. As data accumulated, scientists ran into a contradiction that still has no clean solution. They called it the spin paradox. Theory 1. The fast spin analysis of 3I Atlas's columnated gas jets, narrow, focused streams of material, suggested the nucleus might be spinning once every 12 minutes. 12 minutes. That is incredibly fast. At that speed, centrifugal forces should rip a normal comet apart. For 3I Atlas to survive, it would need exceptional tensile strength, a monolithic or metallic core, or an internal structure far stronger than expected. Theory 2. The slow spin. At the same time, astronomers observed the object's anti-tail, a narrow dust spike pointing toward the Sun. This feature rotated at a predictable rate of 30 to 35 degrees per day. That rotation matched orbital mechanics perfectly. Slow, stable, passive. The problem: one object should not be able to rotate at two radically different speeds simultaneously. Fast enough to generate tight gas jets, and slow enough to maintain a stable sunward dust feature. This contradiction doesn't point to artificial control, but it does expose a serious gap in comet physics, especially for objects formed outside our solar system. 3I Atlas wasn't breaking the laws of physics. It was showing us how incomplete our understanding still is. Chapter 4. The chemistry that settled the debate. While rotation puzzled scientists, chemistry provided clarity. Spectroscopic analysis revealed something crucial: hydroxyl, OH, molecules. Hydroxyl forms when water ice sublimates under solar radiation. Its presence is a definitive signature of a natural comet, but there was more. Astronomers also detected extensive X-ray emissions surrounding the object. These X-rays are produced when a comet's gaseous coma interacts with the solar wind, another unmistakable natural process. This alone strongly argued against any artificial origin. Yet the most important discovery lay deeper. Chapter 5. A cosmic time capsule. The final confirmation came from isotopic ratios. Atoms of the same element can have different numbers of neutrons. These are called isotopes, and the ratios between them act like cosmic fingerprints. In 3I Atlas, scientists measured ratios such as carbon-12 to carbon-13 oxygen isotopes. These ratios were skewed compared to everything in our solar system. This was the smoking gun, proof beyond debate. 3I Atlas was not native to our sun. It was forged in another star system, under different conditions, billions of years ago. A true interstellar time capsule, carrying frozen material from a distant cosmic neighborhood. Whatever else it was natural. Chapter 6. The trajectory that showed no intent. If 3I Atlas had been a probe, its trajectory would have raised questions. But it didn't. Its path was purely gravitational. No thrusts, no corrections, no lingering near Earth. During its closest approach, the Deep Space Network and radio telescopes worldwide listened carefully. No radio signals, no laser pulses, no structured emissions of any kind. The object didn't slow down. It didn't turn toward Earth. It didn't acknowledge us at all. If this was technology, it was profoundly uninterested in us. That reality forced even the strongest proponents of the artificial hypothesis to reconsider. Chapter 7. Avi Loeb's revision. Harvard astrophysicist Avi Loeb has long argued that science should remain open to extraordinary possibilities. But in the case of 3I Atlas, the evidence changed his position. Based on the overwhelming chemical and observational data, Loeb publicly stated that 3I Atlas is most likely natural, not a probe, not a relic of alien engineering, but an exceptionally strong interstellar comet. NASA and ESA agreed. Their conclusion: 3I Atlas is ancient, pristine, and scientifically priceless. Its anomalies don't indicate design. They reveal how little we know about objects formed beyond our solar system. Chapter 8. A humbling passage. Perhaps the most profound lesson of 3I Atlas isn't scientific. It's philosophical. The object didn't arrive with purpose. It didn't bring a message. It didn't care that Earth was here. We were simply bystanders, watching traffic pass through the galaxy. For centuries, humanity imagined itself as a focal point. 3I Atlas reminds us we are not the center. Interstellar material moves constantly between stars. Some of it carries water, carbon, organic molecules, the raw ingredients of life. Life's chemistry is not rare. It is everywhere. Chapter 9. A busy galaxy, a quiet message. 3I Atlas confirms something extraordinary. The space between stars is not empty. It is active, dynamic, filled with relics of planetary systems long gone. As new observatories like the Vera C. Rubin Observatory come online, scientists expect to detect many more interstellar visitors. Each one will tell a story, not of aliens watching us, but of a galaxy rich in material, history, and potential. Final verdict: what 3I Atlas really was. 3I Atlas was not a spacecraft, it was not a probe, it was not a message, it was something more subtle, and perhaps more important. A natural interstellar comet, older than Earth, stronger than expected, carrying water and carbon forged around another star. Its legacy isn't fear, it's perspective. We live in a galaxy filled with moving matter, silent travelers, and shared chemistry. The universe is not speaking to us, but it is passing by, and next time we'll be watching more closely.